Hey guys, Mr. Riss here. So I'm going to help you out finish the 1.3 notes for calculus here. And what we're going to look at is just how to evaluate this delta x problem more and more, because this is going to become a really important problem going on. First, just to make sure we cover something, if you guys see any trig functions, we're just going to use the calculators, use those tables that we've used before. We'll eventually, when we learn the shortcut, we'll go back to trig functions. But for right now, there's a thing called the squeeze theorem, and I think it's just too much right now for us to do. So if you ever see a trig function, just go ahead and use your calculator and estimate the limit. So what we're going to do next here is to find these, and we're going to find the same thing. We're going to find the limit as delta x approaches 0 of f of x plus delta x minus f of x over x, or all over delta x. Now, what we're going to do first is to use different equations here and get them a little bit increasingly difficult. So for our first problem here, we got 3x minus 2 is our f of x. So if I was going to set up this problem here, remember, we're going to break this up into 3 parts. So this first part is, what is f of x plus delta x? So I'm going to find the limit as delta x goes towards 0 of, all right, here's f of x. If I wanted to do f of x plus delta x, that's going to be 3x plus delta x minus 2. And then if I wanted to do minus f of x, I would have to put minus. F of x is just 3x minus 2 all over delta x. Okay. We're going to see what this looks like when we simplify it and then evaluate the derivative, or not derivative, speaking ahead, evaluate the limit. So technically we should always rewrite the limit here, but kind of rule of thumb, if you just remember to take the limit at the end, it's good. So let's distribute the 3. So we get 3x plus 3 delta x minus 2. And we'll distribute this minus 3x plus 2 over delta x. So I could eliminate the 3x's here. I could also eliminate the minus 2 and plus 2. And we'd get a 3 delta x over delta x. And really, this is the limit as delta x approaches 0 of 3. Now, since there is no delta x, we can just plug it into nothing, and so our answer would just be 3. So this first one here is 3. Okay, so you see what we're going to do is we're going to plug in x plus delta x wherever we see an x. Then we're going to put a minus. We'll rewrite the equation here and put this all over delta x. So we're going to simplify it, evaluate the limit, and then get our answer. So each time we do this, it'll be a little bit more difficult, but we'll take our time. So let's look at the next one. Okay, so if I'm going to rewrite this equation, but changing all my x's to x plus delta x's, technically we're doing the limit as delta x goes towards 0 of, well, the first part would be x plus delta x squared minus 4x plus delta x. Okay, so that's the x plus f of x plus delta x. I changed all my x's to x plus delta x's. Then I'm going to put minus f of x. So I'm going to put minus. Now I like to put it in parentheses. It keeps it separated for me, and I kind of know what's going on. Minus x squared minus 4x. And then everything's going to be all over delta x. So let's see. If I were to FOIL that out, that would become x squared, and then we'd have 2x delta x's, and then a delta x squared if I were to FOIL that out, and we did that last time. And then distribute the minus 4, so minus 4x minus 4 delta x, and then distribute the minus sign here, minus x squared plus 4x all over delta x. Okay, so we got a lot of things canceling out. We got this x squared here and this minus x squared. That goes away. We have a minus 4x and a plus 4x. That goes away. And well, I guess that's it. So we're left with a 2x delta x plus delta x squared minus 4 delta x. And this is all over delta x. Well, we can't take the limit yet because we still have a delta x in the bottom, but the top part now is all has delta x. So I could factor out a delta x. And this becomes a 2x plus 1 delta x minus 4 all over delta x. And now our delta x's can cancel out. So really what we're doing here is the limit as delta x approaches 0 of a simpler equation, 2x plus delta x minus 4. So if we take the limit as delta x goes to 0, we're going to just direct substitute the 0 for delta x. We get a 2x plus 0 minus 4. So this answer here would just come out to be a 2x minus 4. Okay, that's it. Looking good. All right, now we get to do the tough one. All right, let's pick a good color. All right, so let's rewrite this equation here. So this would be the limit as delta x approaches 0 of 1 over x plus delta x plus 3. Okay, just rewrote the equation, changed the x to an x plus delta x, and then minus 1 over x plus 3. This is our f of x. And then put this all over delta x. Okay, so we have to remember our rules when we have fractions. When we have fractions, we have to have common denominators. So I'm going to have to multiply this one by an x plus 3 over x plus 3. And I'm going to have to multiply this by an x plus delta x plus 3 over an x plus delta x plus 3. Okay, so we still have the limit going on, but this is going to become an x plus 3 over the common denominator. And then minus an x plus delta x plus 3 over its common denominator. Now we could distribute this, but you'll find out it's just easier to leave them all like so. And then this whole thing is all over delta x still. Okay, so let's combine like terms. So we got our common denominator of x plus 3 times x plus delta x plus 3. And what would this get? Okay, we have x plus 3 minus x. Okay, well, that cancels out the x. And then plus, okay, well, minus, because we'll technically have to distribute this minus sign to all three of those. So we'd have a negative delta x. And then the negative 3 will cancel out that positive 3. Okay, there's that. And then we have this whole thing all over delta x still. So all I did on this top part, combine the numerators, which just cancels out a lot except for a negative delta x. We have this. Well, now what we can do is remember that the delta x, if we divide, we can take our expression. We could times this by 1 over delta x, which cancels out this. And so really we have the limit as delta x goes towards 0 of negative 1 over x plus 3 times x plus delta x plus 3. This is something we can use direct substitution in, because we would get negative 1 over x plus 3 times x plus 0 plus 3, which is just another x plus 3, but the answer here would be negative 1 over x plus 3 squared. Okay, so this is a process we're going to take a long time with. In fact, the next section pretty much just goes over this the whole time and what this means. But let's look at the CYU to see if there's a difficult problem, and we'll go over how to do that one. So clear everything out. Remember, if you guys get stuck, just go ahead, pause the video, or go back, press the J to rewind 10 seconds if you're watching this on YouTube. It's a pretty nice little trick there. All right, so each one of these problems, we are going to find the limit as delta x approaches 0 of x plus delta x. Okay, so same thing. That one should be easy. This one isn't too bad. X squared. All right, we got the square root, or we got a fraction. Well, that one looks familiar. That one shouldn't be too bad. We got that one as well. Let's do the square root because we haven't done that one. So if I was going to do the square root here, I would have the limit as delta x approaches 0 of, okay, this would be the square root of x plus delta x minus the square root of x all over delta x. Just replaced everything with the x plus delta x, then put a minus sign, put the function, and then put it all over delta x. Now, when we have square roots, we need to multiply by the conjugate. That's how we get rid of the square roots. All right, so this is going to become, let's see, the bottom is going to be our delta x times radical x plus delta x plus radical x. And the top is going to be, well, if I FOIL this out, x plus delta, radical x plus delta x times radical x plus delta x is just x plus delta x. And then the middle terms would cancel each other out because we'd have a positive radical x plus delta x times radical x, and then a negative, same thing. So all I have is the negative radical x times radical x, which is a negative x. Well, that just is nice because the x's cancel out and we get a delta x over delta x times our conjugate, which then the delta x's cancel out and we get 1 over radical x plus delta x plus radical x. So we're going to take the limit as we go towards 0. So I'm going to change this delta x to a 0. So we get 1 over radical x plus 0 plus radical x, which we get 1 over radical x plus another radical x, which is 1 over 2 radical x's, which is that choice right there. All right, so you guys should be all right here. On any difficult problem, remember, try your best, but it is multiple choice and you guys can retake this. You guys should be all right. All right, so this wraps up section 1.3. We're actually going to take a quiz over this. So you guys will see that coming up soon. And yeah, we'll go that before we get into the crazy stuff with 1.4 and 1.5. I guys have a great day. If you have any questions, just reach out, but I will see you guys next time.